Welcome to Astronomy Daily, your source for the latest news from the cosmos. I'm Avery.
And I'm Anna. Today, we're diving into some fascinating developments that span from our own moon to the far reaches of our galaxy.
We've got quite the lineup today. A lunar rover gets a second chance at life, an asteroid threatens to pelt our moon with debris, ancient glass reveals secrets from millions of years ago, and astronomers have created the most detailed map of stellar nurseries in our galaxy.
Let's start with some good news from NASA. The Viper Lunar Rover, which was facing cancellation just months ago, has been given a lifeline after NASA spent $450 million on the project and then canceled it in July 2024 due to cost overruns. It looked like the car-sized rover would never see the lunar surface.
But here's where it gets interesting. NASA has struck a new deal worth $190 million with Jeff Bezos' Blue Origin under the Commercial Lunar Payload Services program. This partnership will send Viper to the moon's south pole in late 2027, where it will hunt for water ice deposits for about 100 Earth days.
This mission is crucial for NASA's Artemis program goals of establishing a sustainable lunar presence. Water ice isn't just scientifically interesting, it's a resource that could support future human missions. The rover will be able to analyze the composition and distribution of ice deposits, giving us a much clearer picture of what's available for future lunar explorers. What's particularly impressive about this rescue is the technical specifications of Viper itself. This rover is no lightweight explorer. It weighs about 430 kilograms and stands 1.5 meters tall. It's equipped with 4 scientific instruments specifically designed to analyze water ice, including a neutron spectrometer and a drill that can dig up to a meter into the lunar surface.
The choice of landing site is also crucial here, Anna. The moon's south pole region experiences what scientists call permanently shadowed regions, areas that haven't seen sunlight for potentially billions of years. These could be like frozen time capsules, preserving water ice and other volatiles that could tell us about the early solar system.
Exactly. And the data Viper collects will directly influence where future Artemis missions land. If the rover finds accessible water ice deposits near potential landing sites, it could dramatically change our approach to lunar exploration. Water isn't just for drinking. It can be split into hydrogen and oxygen for rocket fuel, essentially creating a gas station on the moon.
It's a great example of how public-private partnerships can salvage important scientific missions. Sometimes it just takes finding the right partner with the right capabilities and timeline. Now, speaking of lunar threats, we need to discuss something a bit more concerning: Asteroid 2024 YR4.
This asteroid has a 4% chance of hitting our moon in December 2032. Now, while that might not sound like a direct threat to us here on Earth, the consequences could be far-reaching. If this asteroid does impact the moon, it could create a massive amount of debris that would increase micrometeoroid impacts on Earth by up to 1,000 times.
That's where things get really problematic. This debris cloud would pose serious risk to our satellites and any astronauts working in space. We're talking about potentially damaging or destroying critical infrastructure that we rely on for everything from GPS to communications.
What makes this situation particularly challenging is that asteroid 2024 YR4 was only discovered recently, giving us limited time to study its characteristics. The asteroid is estimated to be between 40 and 100 meters in diameter, which might not sound enormous, but at cosmic velocities, even relatively small objects can cause tremendous damage.
The timeline is also tight. With the potential impact in 2032, we have roughly 8 years to mount a response mission. That might seem like plenty of time, but space missions require years of planning, development, and travel time. If we decide to attempt deflection, we'd likely need to launch by 2028 or 2029 to have the best chance of success. Scientists have identified several options for dealing with this threat. The preferred approach is deflection, but there's a big challenge. We don't know the asteroid's exact mass. Current estimates range from 51 million to 711 million kilograms, and that uncertainty makes it difficult to plan an effective deflection mission.
If deflection isn't feasible, destruction becomes an option. This could involve a kinetic impact designed to break the asteroid into manageable 10-meter chunks, or, in extreme cases, a nuclear option using a 1-megaton warhead. The good news is that there's a possible reconnaissance mission in 2028 that could help us better assess the asteroid's mass and composition.
It's fascinating how these seemingly distant cosmic events can have such direct implications for life on Earth. While a 4% chance might seem relatively low, the potential consequences are significant enough that we need to take this threat seriously and prepare accordingly.
Absolutely. Now, let's shift our focus to a discovery that takes us much further back in time. Australian researchers have uncovered evidence of a previously unknown asteroid impact that occurred 11 million years ago.
This discovery came through the identification of new tektites. Those are glass pieces formed when an asteroid impact melts and launches rock material into the atmosphere. These particular tektites, called anangoids, span an impressive 900 kilometers across South Australia.
What makes these anangoids particularly interesting is that they're chemically distinct from the famous Australasian tektites that formed about 780,000 years ago. This means we're looking at evidence of a completely separate impact event, one that had been hidden from scientific view until now. The formation process of these tektites is absolutely extraordinary when you think about it. The original asteroid impact would have generated temperatures exceeding 2,000 degrees Celsius, instantly vaporizing and melting rock material. This molten debris was then hurled hundreds of kilometers through the atmosphere before cooling and solidifying into these glass fragments that we're finding today. The mystery deepens when we consider that the actual impact crater remains undiscovered. Researchers believe it may be located somewhere in the volcanic arcs around the Philippines, Indonesia, or Papua New Guinea. The fact that we can find evidence of the impact spread across such a wide area, yet still haven't located the source crater, really speaks to the challenges of studying these ancient cosmic events.
This discovery is significant because it establishes a sixth known tektite-strewn field globally. Each of these fields represents a major impact event in Earth's history, and finding a new one helps us better understand the frequency and scale of asteroid impacts over geological time. It's like finding a missing piece of Earth's cosmic collision history.
Now, let's journey from impact events to stellar creation. Astronomers have created the most detailed 3D map ever made of stellar nurseries in our galaxy, and it's absolutely breathtaking.
This incredible map was created using data from the European Space Agency's Gaia telescope, and it covers a vast region extending 4,000 light-years from our Sun. The map includes some of the most famous star-forming regions we know, like the Orion-Iridian superbubble and the Gum Nebula.
What's particularly fascinating is how this map reveals the dramatic influence of massive O-type stars on their surrounding environments. These stellar giants are like cosmic sculptors, creating enormous cavities in space where gas clouds rupture and stream outward.
It's a complex dance of creation and destruction. While these massive stars can trigger new star formation by compressing nearby gas clouds, they're simultaneously disrupting the galactic environment around them. The map shows us these processes in unprecedented detail, giving us new insights into how stars are born and how they reshape their cosmic neighborhoods.
This kind of detailed mapping is revolutionizing our understanding of galactic structure and stellar evolution. We're not just seeing where stars are, but understanding the dynamic processes that create them and how they influence the broader galactic ecosystem.
Speaking of revolutionary discoveries, I want to highlight some exciting developments in exoplanet research. The James Webb Space Telescope has been delivering unprecedented insights into atmospheric compositions of distant worlds, and recent findings suggest we might be much closer to finding potentially habitable exoplanets than we previously thought.
What's particularly exciting is Webb's ability to detect water vapor, carbon dioxide, and other key atmospheric components in exoplanet atmospheres. Just last month, researchers announced the discovery of water vapor in the atmosphere of a rocky planet called K2-18b, located about 120 light years away. While this planet might be too large to be truly Earth-like, it's showing us what to look for in our continued search.
The precision of these atmospheric analyses is truly remarkable, Hannah. We're essentially doing chemistry experiments on worlds that are hundreds of light years away. The next generation of ground-based telescopes, like the extremely large telescope currently under construction in Chile, will push these capabilities even further, potentially allowing us to detect biosignatures in exoplanet atmospheres.
I also want to touch on something closer to home. Our sun's recent activity has been quite remarkable. We're currently approaching what's called solar maximum, the peak of the sun's 11-year activity cycle, and the implications for both space exploration and life on Earth are significant.
Over the past year, we've seen some of the strongest solar flares in decades, and this increased activity is creating both challenges and opportunities for space missions. On one hand, the enhanced radiation environment poses risks for astronauts and sensitive electronics on spacecraft. On the other hand, it's providing unprecedented opportunities to study solar physics and space weather.
The practical implications are enormous. Strong solar storms can disrupt GPS systems, interfere with radio communications, and even threaten power grids on Earth. But they also create those spectacular auroras that have been visible much farther south than usual this year. It's a perfect example of how our nearest star continues to surprise us and shape our technological civilization.
Before we move on, I should mention that NASA's Perseverance rover on Mars continues to make remarkable discoveries. The rover has now collected 26 samples from the Martian surface, including some that show strong evidence of ancient microbial life. These samples are waiting for the Mars Sample Return mission, which will bring them back to Earth for detailed analysis in the late 2020s.
The Mars Sample Return mission is really the holy grail of planetary science right now. If those samples do contain evidence of past life, it would fundamentally change our understanding of biology and our place in the universe. And the engineering challenges of bringing samples back from another planet are absolutely staggering. It's almost like a preview of what we'll need to master for eventual human missions to Mars.
Before we wrap up, I want to quickly mention an intriguing study that suggests aliens could potentially eavesdrop on our spacecraft communications using the same methods we use to detect signals from distant probes. It's a reminder that as we reach out into the cosmos, we might also be announcing our presence to any civilizations that might be listening.
It really puts our cosmic activities into perspective. Every signal we send, every probe we launch, could potentially be detected by advanced civilizations using technology similar to our own.
That's all for today's episode of Astronomy Daily. From Anna and me, Avery, thank you for joining us on this journey through the cosmos.
Keep looking up, and we'll see you next time with more news from the universe around us.